Military robots capable of operating independently have become increasingly common over the past decade. However, the U.S. government's recent announcement has shown that these robotic systems' scale and scope have changed dramatically. It's now clear that the era of warfighting robots has arrived. While advanced robotic systems have been developed significantly for military purposes, many have been based on modifying commercial technology. Although the latest wave of warfighting robots is more capable, affordable, and widely available than ever. Is it true that military robots are an idea whose time has come? Join us as we unveil what happened 8 minutes ago. U.S. testing. It's terrifying $12 billion robots. The U.S. Army has been conducting extensive experiments with robots and emerging technology to develop integrated human-robot fighting formations. The initiative aims to leverage thousands of autonomous weapons systems to counter China's growing power. In addition to their role in combat, these robots have been tested for various tasks such as surveillance, reconnaissance, and logistics. The ultimate goal is to create a more efficient and effective military force that can respond to multiple threats in an ever-evolving global landscape. The U.S. military is exploring using various robotic and unmanned systems, such as drones, for military applications. Additionally, the Army and its partners in the defense industry are working on developing robotic ground combat vehicles. At the same time, the Navy has expressed interest in deploying autonomous vessels and other aircraft. The Air Force has also suggested using as many as 1,000 drone wingmen. Apart from these emerging robotics capabilities, artificial intelligence, AI, can revolutionize military applications by enabling the processing of vast amounts of information about the military of both the user and the adversary. This, in turn, could give military forces a significant advantage when making critical decisions during a battle. However, making quick and decisive decisions in warfare is crucial to achieving favorable outcomes. To gain an advantage over the enemy, it is essential to assimilate and analyze large amounts of information and use it to make informed decisions. The U.S. Department of Defense recently launched an ambitious replicator project to scale up capabilities to counter the strategic competition the People's Republic of China posed. The primary objective of Replicator is to deploy thousands of attributable autonomous systems in the next 18 to 24 months, using cutting-edge technology such as AI, robotics, and commercial systems. The Replicator project aims to integrate new and emerging technologies, especially from the private sector, into the military's operations framework. However, there's a growing concern that the Department of Defense's current initiatives and processes may not be enough to tackle the immediate challenges and that the planned level of change may not be adequate, leading to a risky, incremental approach. Similarly, AI and advances are combined to create a range of self-guided autonomous AI weapons systems to equip the U.S. military and other advanced nations with an edge on the battlefield. These combat drones are capable of using lethal force without any human officers to command them. Though critics call them killer robots, these devices encompass various uncrewed or unmanned planes, tanks, ships, and submarines that can operate autonomously. Furthermore, the United States Air Force is currently working on a groundbreaking project, the Collaborative Combat Aircraft, CCA, an unmanned aerial vehicle intended to join piloted aircraft on high-risk missions. The CCA program is a multi-pronged initiative proposed by the USAF to test, develop, and implement new autonomous and manned-unmanned aircraft teaming concepts. The main objective of this unique initiative is to rapidly deploy many autonomous unmanned aircraft, officially designated as CCAs, to team with the 5th or 6th generation manned fighter aircraft as part of the USAF's wider Next Generation Air Dominance NGAD program. This program envisions a system-of-systems approach with the next-generation fighter aircraft, weapons, sensors, networking, and battle management systems to maintain air superiority in the coming decades. The CCA program is a critical step in achieving the USAF's vision of enhancing the capabilities of its fleet and maintaining its dominance in the skies. The project is expected to revolutionize how the USAF operates and provide pilots with enhanced situational awareness and decision-making capabilities, thereby improving the overall effectiveness and safety of the missions. The CCA is a significant development in unmanned aviation and a testament to the USAF's commitment to innovation and technological advancement. On a large scale, deploying collaborative and mission-focused CCAs is increasingly viewed as an effective and practical solution to counteract the growing threat of hostile stealth fighters. These CCAs leverage advanced disruptive technologies such as machine learning, autonomy, and AI to ensure optimal safety and performance of current and future fighter fleets, making them highly agile in combat. During the 2023 Air Force Association, AFA, Warfare Symposium held in Colorado, the USAF Secretary announced the plan to introduce at least 1,000 uncrewed CCAs, which will be paired with advanced manned fighters shortly. The keynote speech, One Team, One Fight, highlighted the significant role of these CCAs in enhancing air power capacity against hostile stealth fighters. The proposed CCAs will be a new breed of highly autonomous and mission-focused, unmanned collaborative combat aircraft that will fly alongside fifth-generation and newer human-crewed fighter jets. They are expected to be significantly less expensive yet highly effective in combat roles. Also, the upcoming CCAs are expected to be highly advanced and mission customizable. They will be equipped with cutting-edge sensors, weapons, and other tactical systems, enabling them to perform different functions and operate in various forms. AI-driven autonomous software will allow the CCAs to collaborate seamlessly with manned combat aircraft, providing comprehensive situational awareness, greater lethality, and improved survivability in highly contested environments. The CCAs will be designed to be interoperable with different types of USAF aircraft. They can function as either a manned aircraft teammate, an individual autonomous platform, or as part of a swarm of collaborative drones without direct human supervision. These versatile drones can perform various missions, including carrying weapons and flying ahead of other aircraft to provide intelligence, surveillance, and reconnaissance. They can also relay valuable early warning signals, evade detection, engage in electronic warfare, and strike targets independently or by the rest of the force. With such advanced capabilities, the CCAs promise to be a game-changing asset for the USAF. Fielding multiple collaborative aircraft can ensure comprehensive battlespace surveillance and agile combat employment from different altitudes at different angles, making mission planning more dynamic and flexible. Collaborative Combat Aircraft is the USAF's official designation for the popularly known Loyal Wingman, uncrewed aircraft systems intended to accompany crewed fighter aircraft with similar flight characteristics and execute orders assigned to them by pilots. The USAF is expected to launch a competition in 2024 to develop and acquire the CCA family of advanced unmanned combat aircraft with significant autonomous and interoperable capabilities. The CCA development will leverage some of the existing crewed-uncrewed teaming efforts, including the Defense Advanced Research Projects Agency's DARPA, Air Combat Evolution, ACE program, the Air Force Research Laboratories, AFRL, Skyborg program, and Boeing Australia's MQ-28A Ghostbat, Air-Powered Teaming System project. The ACE program seeks to enhance air combat autonomy by demonstrating AI-powered human-machine collaboration in aircraft dogfighting. The objective of the Skyborg program was to create an open autonomous aircraft teaming architecture and develop a modular and universal core autonomy control software. This would allow the low-cost production and deployment of multiple collaborative drone variants alongside crewed fighter jets. Therefore, the CCA development will be based on the Skyborg autonomy core system. The USAF's proposed 2024 budget includes $51.7 million to transition Skyborg autonomous flight technology to CCA platforms. The Skyborg program, a project to develop autonomous aerial vehicles, has contracted Boeing, General Atomics Aeronautical Systems, GAASI, and Kratos to produce unmanned combat aerial vehicle, UCAV, prototypes in 2020. These prototypes will be used to test the Skyborg autonomous core system. GAAC's MQ-20 Avenger, Kratos XQ-58 Valkyrie, and Boeing MQ-28 Ghostbat are three high-performance UCAVs participating in this program. In addition to these unmanned vehicles, the variable in-flight simulation test aircraft, Vista X-62A, was also utilized to support autonomy testing for the Skyborg program. This AI-piloted aircraft is a heavily modified version of the F-16D Block 30-piece Marble II aircraft, formerly known as NF-16D. Its advanced technology and capabilities make it ideal for testing and developing autonomous systems. Also, the USAF proposes to start a project named Viper Experimentation and Next-Gen Operations Model, Venom, to equip 6 F-16 Viper fighter jets with AI-enabled self-flying capability. It is intended to test and refine the autonomous software for the CCA technology. The USAF has requested $50 million in the 2024 budget proposal to initiate the project. Boeing's MQ-28A Ghostbat is a remarkable uncrewed aircraft and one of the potential candidates for the CCA program. Developed as part of the Royal Australian Air Force's RAF, the Air Power Teaming System, ATS, the program completed its maiden flight on February 2021. Kratos has developed a range of high-performance, uncrewed teaming aircraft that fall under the CCA category. This includes the Kratos Air Wolf drone, UTAP-22 Makos, and the Kratos XQ-58A, each specialized for different mission capabilities. Likewise, after the MQ-20 Avenger demonstrated its autonomous capabilities, the GAASI introduced the Gambit Autonomous Collaborative Platform on March 20. The Gambit family of unmanned collaborative combat aircraft comprises the Gambit 1 ISR, Gambit 2 Air-to-Air, Gambit 3 High-Fidelity Trainer, and Gambit 4 Combat Recon. In addition, the U.S. Army is similarly testing various unmanned ground vehicles and UGVs, while the Navy is experimenting with unmanned surface vessels, USVs, unmanned undersea vessels, UUVs, or drone submarines. The Army has conducted human-machine teaming using capabilities such as intelligence, surveillance, reconnaissance, and strike drones on the battlefield to help humans and unmanned ground vehicles. Bomb disposal robots have also existed for decades. However, armies worldwide use various automated machines for military purposes, including combat, cargo, intelligence gathering, and much more. Instead of independent AI, most military robots are remote-controlled by human operators. The military doesn't usually use the term robot. It calls them unmanned ground vehicles, UGVs, or unmanned aerial vehicles, UAVs. Also, robots' computer brains are becoming more sophisticated due to artificial intelligence, AI, and machine learning. AI is a form of computer program that allows the robot to process information and make decisions independently. Increasingly, the military is introducing autonomous systems that prepare attack plans independently but require human consent before proceeding. These robots are called Lethal Autonomous Weapons Systems, LAWS. Another important thing to remember about military robots is that those soldiers must carry robots designed to help human soldiers onto the battlefield. For that reason, robot builders try to design man-portable designs. A man-portable robot can be carried by a single soldier, usually in a special backpack. The most common robots currently used by the military are small, flat robots mounted on miniature tank treads. These unmanned ground vehicles can tackle rough terrain and usually have a variety of sensors built in, including audio and video surveillance and chemical detection. These robots are versatile, with different sensor or weapon packages available that mount to the main chassis. Virtually all of them are man-portable. Boeing developed the MQ-28 Ghost Bat, an 11.5-meter-long wingman drone that can fly over 3,704 kilometers. It is equipped with various sensors and supports reconnaissance, surveillance, and intelligence missions, utilizing AI for independent flight. It can also be used in conjunction with crewed aircraft. The Ghost Bat's modular system allows the nose of the aircraft to be swapped out with those containing other equipment packages so that equipment modules can vary depending on the mission. Ripsaw M5, developed by Howe and Howe Technologies and owned by Textron Systems, is an unmanned ground combat vehicle, UGV, designed for speed and maneuverability on the battlefield. It can be useful in various applications, from protecting convoys and conducting rescue missions to setting up perimeter defense, surveillance, bomb disposal, patrolling the border, and crowd control. The UGV has excellent situational awareness, with mounted cameras providing 360-degree coverage to the operator. Again, the MISS, developed by Milrem Robotics, is a ground vehicle meant to reduce troop numbers on the battlefield. It can be reconfigured for transport, attack, ordnance disposal, and intelligence operations. The car can reduce soldiers' load and support logistical activities at a base or for last-mile resupply. It can be used to carry mortars of up to 81 millimeters or configured to help quickly evacuate casualties to medical facilities. Another one is RoboBee, developed by Harvard's Microbotics Laboratory. A tiny flying robot for both military and civilian purposes, the RoboBee is smaller than a quarter and can fly and swim. It is equipped with sensors and electronics that mimic the eyes and antennae of bees, so it can dynamically interact with its environment. The tiny robot could be used for surveillance and search missions, crop pollination, disaster relief, and high-resolution weather monitoring. Large groups of RoboBees working with coordinated behavior are in the works. The TGOST 4, developed by Anduril Industries, is also available. It is a quiet, smart, and modular UAS geared for intelligence, surveillance, and reconnaissance missions, but can also be used for delivering cargo, electronic warfare, or fighting intrusions. It is less than 3 meters long and has vertical takeoff and landing capabilities, VTOL. It is weatherproof, can withstand high winds and other difficult flight conditions, and can be submerged 1 meter. The Striker X was also developed by General Dynamics. It has a wide range of technologies to support soldiers in battle and allows unprecedented cooperation with the operators. It can shoot laser weapons, launch drone attacks, and carry out electronic warfare. It has a hybrid electric engine for quieter operations, so the vehicle can conduct reconnaissance missions. It also has an unmanned 30mm cannon for long-range firing. Then, there is the Jaguar, which the IDF and IAI developed. The Jaguar is a robotic vehicle that replaces soldiers on the battlefield and for border patrol missions. The vehicle has high-resolution cameras, headlights, a communication PA system, and transmitters. It also has a machine gun that can shoot while stationary or on the move and can self-destruct if captured by the enemy. Also, Dogo was developed by General Robotics. It is a small tactical combat robot that is a UGV watchdog for soldiers in the field and is meant to assist in anti-terrorism operations like urban warfare or hostage rescue. A touchscreen can control the Dogo, armed with a 9mm Glock pistol, and it can utilize its heavy-duty treads to traverse any terrain. Dogo is very portable and can be carried one-handed by a soldier. The UGV has 8 cameras, a 360-degree view, and two-way audio, which can be employed in negotiations. Similarly, the Mars was developed by Kinetic. The Mars, Modular Advanced Armed Robotic System, is a UGV for reconnaissance, surveillance, and target acquisition. Mars can keep a safe distance from enemy fire while carrying out various security missions, including ambushes, hostage rescue, forced entry, and more. It has motion detectors, day and night cameras for driving and situational awareness, a microphone, and a loudspeaker, and it can move at 11 kilometers per hour. Its weapon arsenal includes a grenade launcher and machine gun, as well as non-lethal laser dazzlers and audio deterrents. Researchers at Virginia Tech developed the Sapphire. Naval vessels are particularly in danger from fires due to their onboard ordnance and isolation at sea. So, Sapphire, a shipboard autonomous firefighting robot, was created to put out fires on naval ships. The 2-meter-tall robot can handle fire hoses and nozzles, has a wide range of motion so it can maneuver in tight and complex spaces, and can see through thick smoke thanks to its infrared stereo vision sensors, a gas sensor, LiDAR, UV cameras, and a rotating laser. However, over the years, the U.S. military has faced a challenge in finding the right balance between the cost and effectiveness of many and simple versus few and complex systems. After the Vietnam War, the military favored the latter, prioritizing expensive, high-quality equipment. This approach is exemplified by developing more precise weapons built in small quantities to make the most of highly capable platforms. This strategy was born from the fact that the United States could not match the Soviet Union's production of conventional military equipment. Thus, the U.S. invested in technology to enhance its military's lethality, such as the Assault Breaker program, which aimed to deploy increasingly smart weapon systems during the mid to late Cold War. However, the skyrocketing costs of weapons and platforms, recent advancements in emerging technologies, and the resurgence of great power conflict make it progressively challenging for the U.S. military to rely solely on a limited number of advanced capabilities. However, the adoption of robotic and autonomous systems, RAS and AI by U.S. ground forces, carries with it a number of possible implications, including potentially improved performance and reduced risk to soldiers and Marines. Potential new force designs, better institutional support to combat forces, potential new operational concepts, and possible new models for recruiting and retaining soldiers and Marines. The Army and Marines have developed and are executing RAS and AI strategies that articulate near-mid and long-term priorities. Both services have several RAS and AI efforts underway and are cooperating in a number of areas. Although a well-trained workforce is essential to maintaining military readiness, integrating RAS and AI into military units may lead to personnel-related issues that Congress should be aware of, such as changes in unit manning and recruiting and retaining personnel with advanced technical skills, training, and career paths. Some people believe that robots can be programmed to follow rules carefully and may even obey better than humans in the heat and confusion of combat. However, others argue that robots may not fully understand the situation and attack when they shouldn't. For example, the Phalanx close-in point defense gun and the Patriot surface-to-air missile have previously experienced problems as autonomous military systems. Therefore, one great concern about autonomous systems remains. Can robots used in warfare conform to the laws of armed conflict? Thanks for watching. While you're still here, click on the link on your screen to watch another of our interesting videos. See you there.